everyone. We are the Brookhaven National Laboratory and Ecolong team for the RTEM Hackathon. The BNL team was led by Shinjae Yo, and the Ecolong team was led by Nancy Min. Using the rich RTEM data set with over 200 buildings worth of data, the project team focused on two major areas with the broadest potential for energy savings. The first being optimizing programmable settings based on occupant schedules and occupant comfort requirements, and the second being automatically detecting and diagnosing equipment operation.
The first solution we developed is an adaptive load forecasting system. This system can forecast load usage at the building or device level. The primary benefit of our approach is its ability to automatically adapt to environmental changes such as occupancy, weather, economic conditions, and more. When we looked at the electrical load data in the RTEM database, we found significant variations in daily, weekly, and seasonal usage. For example, multifamily residences tended to have a peak usage in the mornings and evenings during the weekdays, but these peaks were absent on the weekends. This was most likely caused by occupancy patterns. We also saw seasonal variations with peak usage during the summer months. These observations motivated us to develop our adaptive system. We developed a system based on recursive least squares. Based on autoregression, this uses a computationally efficient update formula to update the model as new observations arise. We compare here our proposed method to a baseline persistent model, and we see that our method outperforms the persistent model by around 50% for both 1 hour ahead and 24-hour ahead predictions.
Building performance analytics and fault detection tools are increasingly used for operational efficiency in today's commercial buildings. Previous research found that AFDD reduced building electricity cost by 8 to 20%. Analysis on RTEM buildings showed that this approach can identify commonly occurring issues and possible fields of improvement. Example A showed a systematic error of consistent warm bias between 5 and 8 a.m. UTC that requires further investigation. Example B represents an instrument calibration error where supply air temperature measured consistently below 40 Fahrenheit, then jumped up towards the end of March. And in example C, we can notice that the duct tape pressure dropped to 0 during the nighttime, while the set point stayed in 1, resulting in possible false alarms. Based on the findings from the RTEM data, the team identified a series of fault conditions and possible correction methods. Some examples are listed in Table 3.